Okay, so here we are in coding screen. So you can see here, this is the code where models are defined and the training data has been given for all the KRIs. So you can see here, base models, same I told you, multiple classifier, random forest, gradient boosting and all, extra tree and cat boost classifier. For first, for three reports which are relocation, validity and landline. And similarly, for revenue reconciliation report, these are the base model. You can see MLP 1, 2, 3, 4, 4 MLP classifier, which are part of ANN model, and then random forest gradient boosting, extra tree, and cat. What I have done, I have already ran that code and I have saved the model file because it will be very easy to. We have already saved the model file, then it will be less time consuming to just generate the reports. Same three files are being used, and then we will generate the reports, but this will be machine learning based. So you can see in no time, in a very less time, it will generate. So also I will show you the email window. So we already have these correct system generated reports, and we will compare the stat with the machine learning. Okay, so let me hit this code. I mean run this code now. Okay. So loading models and scalars, you can see on the coding screen, output screen. It is coming. It is loading models and scalars. Then the predictions will be made, and the report will be generated. Just check the email window and come back. And in the meantime, I will show. Yeah, same. Four reports will be attached to the email part, and I will show you that there. Yeah, see. The already wow, what about all the stats are being published and prediction process completed successfully. That's I want to show you that this will be happen in no time. I mean very less time if the already model files are saved and loaded now. Email sent. So we'll go to the coding screen and yeah, you can see we can see here. Wow, ML based D2H audit report relocation charges recalculation extra validity revenue all four have arrived. Let's start with landline charges. How much? See. Okay, so already the same code discrepancy cases will be highlighted in the email body. So what it said, ML based D2H audit report. This date is this much date. This date and landline charges reconciliation report. Dear user, this is a ML generated D2H audit report for this date regarding landline charges reconciliation report. Kindly find the CSV report attached with this mail. Discrepancies exception found are 28 cases. Recommendation: please review the attached report and take necessary corrective action immediately. So 28 cases, okay, and the CSV file is there. So we will just check, go back and check for this landline charges system generated report was how much? 28. So 28, wow, beauty, beauty, 28. Same, correctly identified. Then we will go to extra validity. This is ML generated for extra, extra validity reconciliation report. How much? 21. Discrepancy exceptions found 21. These are the exceptions, and this is the recommendation. And we will just check the count 21 for extra validity reconciliation report. 21 should be there for extra validity here. 21 in rule base also that was 21. So this one also correct. Now relocation charges reconciliation report discrepancies found. 31 cases are found there. Okay, so we go to landline. Sorry, which was there? Okay, relocation 31. So same 31 there and 31 for ML base due to which report regression charges exceptions are 31. Rest last is revenue. Oh wow, what a beauty. See ML based D2H auto report. This one 19th Feb revenue charges cancellation for the user ML generated or D2H auto report. Okay, discrepancies exception found six. So six was there. I told you in Excel also in system based also. I mean rule based also. See predicted label. Wow, what a beauty. I told you no zero is for incorrect, one is for correct, but only zero will be showing in email body. So these six cases ending with customer ID to 26, 28, and up to 38 are shown. And this is the current revenue that was in incoming record file. I mean that is coming in daily revenue. This one daily revenue file. So this one column ML based algorithm has compared this, and when comparing with this and the predict label, it has to generate that whether it is correct or not. So this is the calculated revenue. This is system based calculation. Means the classification model will just predict the zero or one. Let me show you. You will get an idea now. This one because it has both one and zero cases. See, one are correctly charged and zero is the discrepancy. So that's why in email body zero cases were only coming. So zero stand for discrepancy. But you can see here the thing is I will show you. You can see that how closely this case ending with 28. I mean customer ID ending with 28 1000028. Current revenue is 6.68 and calculated revenue is 6.78. Matlab, means this one is calculation based, but our model as was trained. This column I have added for showing purpose. This was not needed, but I want to compare the results and I want to show you. So these are the cases which are incorrect because this they see current revenue is $12.90, but it has to be $7.02 according to our old KRI as well. This is the simple formula that we used in calculate rule based KRI. But I add this column to show you that how good is this classification model. See for this case the difference is 10 cents only. 6.68 and formula is 6.78, but our model has already predicted not on this basis but on the training data it has predicted is as a incorrect zero discrepancy. Why? Now I will tell you. I will go to the coding screen and I will tell you. This is the prediction code and this is the training code. So when we designed this revenue data KRI, you can see here we have given the tolerance of zero, sorry, 1%. See here, I have not told you before because I want to first want to show you the results and then 1%, and this is 1%. This is not under 1%. So more than 1%, it will show a discrepancy. So see, this is some logic we have already given for classification model that classification has to learn. So wow, what a beauty. Okay, so if I even if I ever just download this in front of you, sorry, download, download. I will show you that how this works. So we have trained the model to to tolerance of 1%, and I even open this file. Okay, don't angry on me. It's just opening. System is being heavily occupied with these data recording and models. I mean these codes, heavy codes. Okay, so here is the data attached with the email. So see, for particularly this case, I told you for discrepancy case, I will highlight this. Where only 10 cents and the model was able to judge between right and wrong. See, ah, this one 6.68, 6.78. So I told you this column is being put in by me, but model has already judged through the tolerance level given in the training data, and it has understood that this is incorrect, and I will just and what I'm doing is I'm showing you that I'm not making this up. I'm just giving you. Let's have the formula. So if current revenue minus calculated revenue divided by current revenue into 100, and see, the tolerance is 1.49, means more than 1%. And I what I told you, let me show it to in the number format also. Now I told you the tolerance level is plus or minus 1%. If it is more than 1%, we have given that in training code here. This one there, you can see. So the model has to learn that more than 1%. I have the case should be flagged, and that's why at that level the labels were being of 0 1 at that time. These labels, this is the predicted labels, but in training labels also we have put the tolerance of 1%. So it has learned the same way. So I told you that these ML models are very valuable, and they learn from the hidden pattern as well. But this was being given, so that's why they always stick to the rules whatever they have been trained upon. uh, they will follow. So similarly, if you want to see the tolerance level, you can see here for other discrepancy cases, so much. Okay. Only 1% something, 1.5% something is this, then 30%, 62%, 18%, 61%. So it has to highlight those cases. If I you can see here 45.58, and if I move forward for the correct cases, you can see here 0 0 0 0. So this is live. I'm not making this up. Tolerance level is 0 0 0. So why will it flag it as a discrepancy? So that's why correctly charged. Wow, what a beauty, absolute beauty of machine learning models or AI models. So this is something when you are a subject matter expert, you can design this way, and you can understand the model behavior. That's why I put so much of ML models in that. That's the margin of error will be negligible. Okay, and same for this. I will show you through regression model also, where we will generate these values. These will generate these values. Main model regression model will predict these values. It will not calculate. This is manual calculation. I showed you for I add this column for for representation purpose, but actually now regression model will predict these values little bit upside down, but we will adjust accordingly. And then the main thing is to fine tune the model to be as correct as these this formula values. So we will show it in now next. Okay, so now we will go towards the regression model. So revenue reconciliation using regression. The goal is to predict expected revenue and compare with actual revenue to flag discrepancies. So we will predict the revenue values now. I told you that this is not formula based. We will predict values. This is model based predictions. So what models we have used? XGB regressor plus CATBoost as primary models, and the secondary models are there also for residual. All regression models are there. Means on that classification, we are using classification models. Now we are using all regression models. So you can see here LGBM, RF, random forest, and MLP is also there, and EET extra tree, and hist gradient model, and then this one is also there, tabnet plus XGB, or a very highly finance model predicts expected revenue dynamically instead of fixed rules. That is the benefit. Okay, and if I go, we go to the next code. You can see here the approach for classification. I already showed flags revenue discrepancies as correctly charged discrepant, quick fraud detection. You can say also that uh, quick correctly versus discrepancy classification. Regression model predicts actual revenue and finds mismatches. Actual revenue is in also we both the models have their own strength. I will show you that in uh, in next how these models have have their strengths. So continuous revenue tracking. So regression models are very good if you want to forecast something, like you want to forecast what will be the value of the customer which will be churned. So the classification model will tell the count that 1700 something subscriber will be are at risk at next month, and regression model will tell that 2,36,000 is the dollar is the estimate that you will lose the revenue. So all models have their own strengths. So okay, so this let me go to the next slide also. So I will tell you the key challenges in implementing, this regression models for audits. That feature selection was very difficult. You can this see this much of features we have used: remaining days, deferred revenue, revenue difference, validity, utilization ratio, revenue change, 7 day rolling change. For 7 days we are watching log deferred revenue. We have checked. We are checking revenue change in 30 days, and we revenue change 7 days, revenue 30 days. So we are checking this also. LF is, LF score is we are checking. I will explain this in next challenges. Okay, so variance computation, fixed versus dynamic tolerance. There was n number. I mean, there are so many. There were so many challenges was there, uncountable challenges. Regression model tuning, handling revenue deviations and expected fluctuation. I will tell you in a very summarized way. And this is something residual distribution plot. This is the last fine tune model have produced. So you can see here also the residual distribution plot is saying that now it is balanced. So you can see plus minus values are towards the same uh, uh, range. Yeah, 3.5% something. So yeah, this is something balanced. So our final prediction model is ready. I have already trained and saved it. So now we don't we waste time, and I have already deleted all the other reports. So because this is the same for only revenue audit report, this regression model will uh, generate the revenue. So you can see and understand now that calculated revenue will be there current revenue will be there. One more column will be added. This predicted label will not be there because this is regression model. So instead of 0 or 1, the values will be uh, like this. So the final revenue column will be added and the values or dollar values will be there, and we will compare those with the current revenue. So it should also flag the discrepancies count should be 6. So this is the main problem, that it has to predict the values as close to the calculated revenue. Then only we can differentiate between current revenue and final revenue. Now I will run the code. Okay, so the code has started running, and it will show the stats as well. This is, I will tell you that this fine tuning requires subject matter expert. Because you have to fine tune the model. I told you through the feature selection, and then there were problems with the fine tuning of through the variance was there, computation, fixed versus dynamic tolerance, handling revenue deviations and unexpected fluctuations. So, but at last, the things were being pulled off. So right now we are waiting. Let's just refresh the email screen as well. Okay, so yeah. So yeah, I want to tell you also that ML revenue. I will explain this. ML revenue report saved. It has been generated and prediction process completed successfully. Email sent successfully. Just go to the, wow, what a beauty! See, we will just compare these reports: revenue, charge reconciliation, classification based, and ML regression based. So if I open this now, wow, what a beauty! See, this is an ML generated D2H audit report, revenue charge reconciliation report. Okay, regression based. Discrepancy is 6. Bang on. See, let's go to this. Discrepancy is 6. Okay, same cases 26 till 38, and here also, oh, sorry, 26 till 38. And now we will compare. See, deferred revenue is also there. Current revenue, that is, that we have to check against that our final revenue. This is the column that our regression model has predicted the values, and this calculated revenue is the correct one. This is the old calculation based. So see now, final revenue $7, 7.02 discrepancy. Okay, I told you. And 6.78, sorry, this one we have to compare 12.90 and 7 discrepancy, 6.78 and 6.68. See, 10% only. Then also discrepancy 9.29, 6.45 discrepancy, 14.29. These are much discrepancy, 5.51, 6.29. But I was telling that how close it has, to the actual calculation, a calculation based revenue, how close model has predicted the values. $7 towards the 7.02, 6.78, 6.0, same. Oh my god, 6.45, 6. Same. This is prediction values. 5.38, same. 5.38, 5.15, 5.15, same. 5.07, 5.07. So can you believe now? Can you believe it? This prediction model, how close, it has, predicted the revenue values. So I will tell you now. I will go to the code part also. Yeah. So see, when I tell you this now, we have given the tolerance level of 2%. See, but you will see, you will ask, if it is 2%, then how this customer ID 1000028 in which current revenue is 6.68 and the model predicted 6.78, which is accurate to the calculation based methodology, calculation based revenue. So you are saying 2% is tolerance level, then this is less than 2%. So why it has not said it as correct rather than discrepancy? Okay, let me download this file also. I will show you. The questions will be asked, addressed. I will open the file regression because it has both, cases, correctly charged and discrepancy now. Sorry. Okay. So you're saying that, you see, 11.91. The model predicted this value, 11.91. Current revenue is 12.12. Then also correctly charged. You will say, what is this? How it is correctly charged? Why? Because we have given 2% tolerance. More than 2%, you will flag it as discrepancy. Sorry. So let me minus this from this, and if I divide again this and into 100, and I will check for all, and I will change the format to number. See, uh, less than 2%. And tolerance level, I told you, if it's less than 2%, then it is correctly charged. So for all these, I will highlight it as green. These are correctly charged. Okay. So for all these cases, you can see the tolerance level is less than 2%. For these all are zero. So they have to be, the status has to be correctly charged. But for this case also, when you are asking that predicted value by model is $11.91 and the current revenue is 12.12, then how it is correctly charged? Why? Because tolerance level is less than 2%, and I have already given that condition. That's why it is being correctly charged. But then again, one customer ID is creating problem. This one, well, I highlight well this one. Why? See, current revenue is 6.68 and final revenue 6.78, and the tolerance level becomes less than 2%. So now your question is why this has not been flagged as you know correctly charged, because you have given the logic. If tolerance level is less than 2%, then all will be correctly charged. If it is more than 2%, then it will be discrepancy. So see, correct. I This one is correct because 45%, 30% something, 62% something, 18% something, 61% something. So all are above 2%, then yeah, it is correct that the model, that status is discrepancy. But for this, it is under 2% though. So why it has not been flagged as correctly charged? Because we have given the condition of 2% as tolerance level plus minus. So within less than plus 2% correctly charged. So less than minus 2%, it should also be correctly charged. But the status is discrepancy. I will tell you now why. See there, I told you na, there is a, the we always use uh, categorized revenue. We always use that auto threshold formula, uh, which will calculate the average and mean. So for that, for this also, no, sorry, here in the prediction code, yeah, here, calculate tolerance threshold. So what is it saying that average, it will check for average, it will check for standard deviation, and if variance is less than equal to 10%, it will use average mean, otherwise it will use average plus standard deviation. So now I have already put in the debug command here. You can see here mean value, I mean average revenue value was 6.99 and standard deviation was 1.62. So variance was to 23.19%, which is greater than 10%. So the condition will become that add average plus standard deviation. That's why 6.99 plus 1.62 become 8.67. Okay, based on this much variance. So above this value 8.61, now you can see above this value 8.61 tolerance level will be 2%. I have already given this condition. This you can do when you know how your model behaves. So here, okay, here you can see here 2%. If current revenue is greater than the threshold, else 1%. So the value of 8.61 something, what is the value? 8.61 here come. Let's go back to the our. You can see here if it is greater than 8.67 then 2%. But this value, is it greater than 8.61? No. This is $6.78. 8.61 is the threshold. So for lower revenues, the tolerance level is 1%. That's why it is more than 1%. So it flagged it as discrepancy. So see, for this correctly, I mean more than 8.61, it becomes 2%. For less than 8.61, it becomes 1%. So that's why it was able to find the status that is correct discrepancy. So that's why if we go back, you can see, wow, what a beauty. All six cases are identified by the regression model itself, which is predicting the final revenue, and then we are comparing the final revenue versus the current revenue. And we have given the auto threshold, which helps in making the status column. So the calculate threshold, tolerance threshold is the function that is helping us. So this ends the project now, and lastly, I will tell you, see that future forecasting can be done by both regression and classification model, and it is very simple. When you have something like this, when you can regression model will produce the values, and similarly, and classification model will predict the status, what will be who's gonna churn, who's gonna not churn, and then you can combine the both models output, and you can make the report like this. If you do Power BI or Tableau, you can see that 1700 at risk subscribers will be there at next month, and this will be the projected loss, like something to $38,000 will in next quarter will be the projected loss. We are going quarterly, then 1700 active subscriber are quarterly. Next quarter will be out of your network. So if I zoom this, expand this, I mean, so classification model is focused on subscriber churn count, like this 1700 subscriber is a predicted value. Business impact is helps identify potential churn risk and take preventive actions. When you know the count, and regression model, it will estimate the revenue loss, that this much will be your loss for next quarter. Helps forecast financial impact and design revenue saving strategies. So in this way, you can use regression and classification models, which have their own strength, as I told you. So guys, this is the closing round. Now signing off. Please take care of yourself. Okay, bye bye.